In this video, what we're going to do is review our understanding of redox from the first year of the course. So why don't you just have a go at filling in these two key definitions? You should know the answers to these two. So there we go, oxidation is loss, reduction is gain. And remember at A level we must say what we're losing or gaining, and that is electrons. So let's have a go at putting that into practice and just reminding ourselves. So can you write a full equation for the reaction of bromine water with a solution of potassium iodide? Pause the video and see if you can write that reaction and give state symbols. So there you go, bromine reacts with potassium iodide to make potassium bromide and iodine. What we're going to do now is try to break that down into an ionic equation. So let's try to remember the rules for writing an ionic equation. Question number one we ask ourselves is it aqueous? If it's aqueous, we might need to split it into ions. If it's not aqueous, we're definitely not going to split it. So solids, liquids and gases are going to stay as they are. We've only got aqueous species here, so is it aqueous? Yes. Is it ionic? So is it made of a metal and a non-metal, or is it an acid? And if it is, we're going to split it up, and if it's covalent, we're not. So bromine, is it ionic? Well, no, bromine's not ionic, so we're going to leave it as it is. Bromine is a simple covalent molecule. Then we're going to look at Ki. Well, it contains a metal, so it is ionic. It's made of potassium ions and iodide ions. But remember that there's two of everything, so we put a 2 in front of both of those. And then we've got potassium bromide again. It's made of potassium ions and bromide ions because it contains a metal. And there's 2 of each of those because there's a 2 in front. And then we've got iodine, which is made of only non-metals, so it's covalent, so we're going to keep it as it is. What we're going to do now is cross out any spectator ions, anything that appears on both sides. And if we get rid of those, because they're spectator ions, we'll be left with our ionic equation. So bromine plus iodide ions makes bromide ions plus iodine. Can you split that into 2 half equations? So can you first of all tell me what's happening to the bromine, and can then you tell me what's happening to the iodide ions? So this is what you should get. Bromine is picking up 2 electrons to become bromide ions, and iodide ions are losing 2 electrons to become iodine. Could you label those as oxidation and reduction? So which one of those is the oxidation and which one of those is the reduction? So if we've got all of that right, we should be able to see we've got these as our answers. Bromine is being reduced and iodide ions are being oxidized in this reaction. Okay, how could we do that a bit quicker? Remember, in our redox pack we looked at using oxidation states. If you've forgotten how to assign an oxidation state, you'll need to go back to the redox pack and have a little bit of a review. What we're going to do here is write an equation for the reaction of copper, sulfate and zinc. Copper sulfate and zinc make zinc sulfate and copper. What I'd like you to do is go across that and put oxidation states on everything. Now bearing in mind we've told you that the oxidation state of the sulfur is +6, that should help you get the copper. So if you've managed that, you should have got the copper was +2 at the start, but at the end it's an element, so it's gone from +2 to 0. Now has that number gone up or gone down? That number has gone down. It's gone down from +2 to 0, so we've got some reduction going on. Yes, we've gone from +2 to 0. The oxidation state has decreased. And for the zinc, we've got it going from 0 to +2. That must be oxidation, because the number has increased. Okay, so it's a bit quicker than doing the half equation method, that. So use that method, find out which element has undergone oxidation and which element has undergone reduction in each of your examples. So there you go. In the first example, the sodium has been oxidised because its oxidation state has increased from 0 to +1, and the hydrogen in the water has been reduced. In the second example, chlorine has been both oxidised and reduced, and remember that the name for this type of reaction is disproportionation, where the same element undergoes both oxidation and reduction. Disproportionation. And in the last example, the sulphur's been oxidised from +4 to +6 and the cerium's been reduced. So our last little bit of recap is what is an oxidising agent and what is a reducing agent? Can you remember which one of those definitions refers to which of those two agents? Okay, so we've got oxidising agent, the species that accepts, and reducing agent, the species that donates. So remember, one of the ways to think about this is the oxidising agent is the agent that causes oxidation. So if I'm going to cause you to lose electrons, I need to take them from you. So I'm going to take them, I'm going to accept them. If I'm going to cause you to gain, I need to give them to you. So I'm going to donate them to you. So have a look at these questions. We have to work out the formula. Now remember, unlike when we do oxidation and reduction, we're not looking at the name of the element, we're looking at the formula of the agent, which is the whole chemical that is causing the oxidation and reduction. So the first job is to put some oxidation states on. Okay, so we look at the things that we know are probably going to change, and it's often things like the transition metals. So I'm going to have a look at this Nn, and each oxygen is -2. So if you think about that, I've got 4 lots of -2, the Nn must be +7, but over here it's +2. So how does it go from +7 to +2? To do that, it must gain electrons, it must accept electrons. Therefore, MnO4-, the whole chemical, is our oxidising agent. The manganate is our oxidising agent. So what's going the other way? What's the reducing agent? Now, normally it's not hydrogens unless you have hydrogen in the element, because H plus is a +1 on both sides. If we have a look at this, we can see that this C in here, each of these oxygens is -2, and we're trying to get to -2. So we're at -8, we need to go up 6, and we've got 2 carbons, so +3 each. Over here in carbon dioxide, the carbons are +4. So our C is going from +3 to +4. To do that, it's giving away electrons, it's donating, it must be the reducing agent. But it's not the carbon that we write down, it's the full formula of the thing that we put in the beaker in order to cause reduction. So manganate was being reduced, the Mn, the element Mn was being reduced by the ethane dioate ions. So the reducing agent was the ethane dioate ions. The carbon was being oxidised by the manganate. So the oxidising agent is the manganate. Why don't you have a go at these three questions, and we'll come back and have a look at the answers in a minute. So there you go. Have a look through those and check your answers. So that's the end of this little recap video. If you have struggled with this, you need to go back to Redox from the first year and have a look through that pack.